Hi, welcome back. In this lecture, I will present how to use Cython annotation to analyze blocks of code generated by Cython. So this will be a short lecture. By the end of this lecture, we will be able to use a Cython annotation tool to identify the parts of the code that call the Python virtual machine most often. So we will focus on those parts later on. What is a Cython annotation? Well, Cython annotation is basically a flag that we can add to Cython when we call it. So Cython has an annotation option that will output a web page in a HTML file that you can view in a browser. How we use Cython annotation? Well, we just call the command Cython -a Cython function.pyx, where this is the function that has our code that has been Cythonized. What Cython -a is going to do? Well, it will output a Cython fn HTML with all the code and some information about how many times that code is calling the Python virtual machine. Here is an example on my laptop. I call Cython -a and then I put the function that we want to compile. So Cython fn.pyx. As you can see here, there's some warning, and then it generated this Cython fn.html, that is the web page that we can open using a web browser to analyze the code. So if I open with my web browser that HTML file, I will see something very similar to what I see here on this slide. So here you have different line numbers of our .pyx Cython code with a few features. So if we click on this plus sign for any of these lines, you will see what is the C code that has been generated and then will be compiled when using Cython. You can see there are a few things. So there are like white lines and also there are yellow ones. You can see also that we have some lines that are more yellow than the other ones. So for instance, this line is more yellow than this one that is very light yellow. What more yellow or less yellow means? Well, more yellow means that that line has more calls into the Python virtual machine. So that's the part that we should focus on. On the other hand, white means that there is non-Python C code. So at this point, there is all Python code, but we have a different degree of how many times the code is calling the Python virtual machine. So our goal when we analyze this is to remove as many of the yellow lines as possible and to end up with as much white possible. That is our compiled code. So we know at this point that each call into the virtual machine has a cost, but of course the cost of the single call will be significant if this has been done inside large loops. So for optimization purposes, we will always focus on the part within the loops, because those are the part that we call many times the Python virtual machine. If we try to analyze the annotated code we got from Cython, we see that the lines with most calls into Python virtual machine are the so-called most yellow, and these are the lines 5 here and 9 here. So lines 10 and 11 and 12 are almost a yellow, and I also know that they are inside the inner loop, so this is getting some importance. Lines 7 and 8 are less yellow, and since they're calling only 1 millionth of time, they will have much smaller effect on the final speed and final performance. So we will focus on them later on. To improve the execution time of our function, we need to start declaring the types of objects that are involved in these expensive inner loops. And we're going to do this in the next lecture. So we're going to look at this variable here, and one way to improve the performance will be to declare the types of the object. And we will largely decrease the cost of these inner loops. So this is the last slides of this lecture. In summary, Cython allows us to identify the part of the code we can focus on for optimization by basically telling us which part of the code are calling many times the Python virtual machine, so we can focus on them. And the annotation tool is very simple to use. We just use Cythons -a and then the pyx function that we're going to compile. This is the last slide. Talk to you soon.